All right, guys, let's talk about taking a line. Okay, so we got a line there, and and turning that path of the line into an equation, right? And we like to see that equation written in slope-intercept form because it's got some great characteristics about it that help us see the future of that path, right, in each direction. So those two things being the slope and the y-intercept. So there's something really cool about having a nice single straight line that we call a linear path. Okay, as long as we have that nice single straight line visible to us, at least with some type of numbered background, overlaid in front of it or behind it, something like a coordinate plane, right? Or maybe even like a real life scenario, we could have like an airplane moving across the sky with the latitude and longitude lines overlaid across it. So it gives us some numbering system, right, that we can use to calculate left and right movement relative to up and down movement. And this is exactly what they use for like GPS programs and things like that. I mean, at a very fundamental level, this stuff we're working with right here is how we actually build computer programs and GPSs and estimated times of arrivals and possible intersections of paths and things like that. So let's dig into this a little bit. So very first thing, we need to know what slope-intercept form is. And if you're not familiar with it, here's what it is, okay? Your y-coordinate always equals your slope, which is little m, times your x-coordinate, plus or minus, and it's usually just written plus, but it could be a minus. I'll just put plus for now, but this could be a minus b, where b is your y-intercept. It's where your line hits the y-axis, all right? So your x and your y's are just a coordinate, okay, like an xy combination, right? A walk and then a fly or a fall. It's just a coordinate. This x and this y value correspond to any point on this line, okay? So like this line has a x coordinate of negative 1, 2, 3, 4, and a fly of 1, 2, 3. So negative 4, 3, right? So x coordinate negative 4, y coordinate 3. Yeah, so that would fit in there, right? And of course, we would have to have a corresponding slope and a y-intercept to make that equation fit. But let's not get into that right now. Let's just look at taking a line and being able to come up with our two significant values, which are I'll highlight them. Okay, the slope. We need the slope and we need the y-intercept in order to translate this straight line path into its slope-intercept form. So let's do that, all right? So very easy, super easy, okay? So first thing I like to do when I see my line is I like to scan through my line. So if they haven't given us two nice points already, we need to scan through this line and see if we can find two very nice known points. And all we need are two. We can find more. All we really need is two. Okay, so I've kind of cheated a little bit. I've got two shown here, but we could find more along here. But I'm going to pick that nice point, and that's a nice point. All we need are two nice points, and we want to draw a right triangle between those 2 points. Okay, this is how I like to do it, okay? So you could draw your right triangle like this, or you could draw it like this. It does not matter. It's just got to be a true right triangle. I'll draw it like this. And you don't even really have to draw this. You could just do this in your mind. But for me explaining and teaching it right now, I'm gonna draw it, make it visible. Okay, so there's our right triangle. Now we need to go gather some information about this right triangle. We need to go find our rise and our run between these two known points. So your rise is your vertical change between these two known points, and your run, they call it, is your horizontal change between these 2 points. So our rise, there's no numbering system here, so we'll just assume that we're going by ones. So we got 1, 2. So our rise is 2, and our run is 1, 2, 3, 4 blocks. So now we can find our slope, okay? We got a rise of 2 and a run of 4. Let's go ahead and calculate our slope. Maybe just over to the side somewhere. Let's throw it in here, okay? So our slope equals rise over run. So rise divided by run. So rise is 2 and run is 4. And from one of my other videos, I let everybody know that Lines that go up and to the right are always positive sloped lines. Okay, so we could make a little note here if you'd like. Lines that go up and to the right are always positive sloped, and lines that go up and to the left are always negatively sloped. They have a negative on their slope answer. That's just how I remember it. There are other ways to remember it, but I think that's pretty easy. Okay, up and to the right, positive, up and to the left, negative. So this line is going up and to the right. So this fraction, this slope answer will have a positive. Of course, I'm not going to put the positive. Any number is positive if it doesn't have a negative to the left of it. So we'll just leave the negative off, and that automatically means positive, right? But that will actually simplify to a simpler form fraction. 2 over 4 simplifies to 1 over 2, and we could also call that 0.5, and we could also call that 50%. Okay, it's an ugly 50, sorry, but 50%. So I'm going to stick with the fraction, though. Typically, that's what we use in our formula. Okay, so I got this. I got our slope. Now let's go get our y-intercept. Hey, our y-intercept is super simple, right? We just got to find out where our line hits the y-axis. What is that y value? Okay, so the y value, the coordinate, right, is at 0, 1, 2, 3, 4, 5. So we want this y value, right? So y equals 5 right there. A fly of 5. So there's our b value, right? That's our b. B also equals 5. B is just another word, or not a word. B is another variable, right? A symbol for where does the line hit the where does the line hit the y axis? Right there. So there we go. We got B. Let's go ahead and write our equation of this line in slope-intercept form. So y equals, y coordinate always equals, so that's always the same, right? Y for the slope-intercept form, we always have a y. We throw our slope in, m, which is 1/2. So we replace m with 1/2 times x. That's always stays the same in this formula, right? Times our x value. There's always going to be a y and an x in this formula. Plus or minus b, well, it's going to be a positive 5. It hits the y-axis at positive 5, so plus 5. So there we go. There's our slope-intercept equation for that line. Super easy. Y equals 1/2 x plus 5. Pretty simple, right? So if we found any point on this line, if we went and plugged that corresponding x and y coordinate value into this equation, it will work. Okay, we're not going to do that right now. We're just practicing finding slope-intercept form, but that's kind of how that would work. So if we wanted to see what this line was doing way out here in the first quadrant, way up in here, as long as we had the xy value of that coordinate, we could plug it into this equation and it would balance. Or if we just had one coordinate, right? If we just had the x coordinate way out here and we wanted to figure out what the corresponding y coordinate was, well, we could plug that x coordinate in and then we could go solve for the corresponding y coordinate. And we wouldn't even have to have this line drawn. Once we get the equation of it, we can figure out what this line is doing way out here in the future, right? Going up or down in either direction. We could solve for either one of these coordinates as long as we had one of them, we could solve for the other. So that makes it pretty handy in predicting the path of this line. Let's try another one. We got another line here, okay? Let's try it out. So we got a good line drawn here. Let's search for 2 known points. Looks like we got 2 nice ones. Got a nice one here, got a nice one here. We probably have some other nice ones on there, but I'm going to pick these 2. Okay, what's the next step? At least the order in which I like to do it. I'm going to go ahead and find the slope. Okay, so I like to visualize or go ahead and draw a nice right triangle between your 2 known points, right? You just connect those spots horizontally and vertically until they connect. Follow your grid line path, right? So there's our right angle, little box there. So there's our right triangle. Let's go count our rise between these 2 known points and our run between these 2 known points. So our run is going to be 2 blocks, and our rise is going to be 1, 2, 3, 4, 5, 6 blocks. All right, let's go ahead and build our slope, right? So m equals rise, which is 6, over run, which is 2. All right, and then of course we always want to try to simplify that if possible, and that divides out to be a nice whole number. So that's going to be 6 divided by 2, which is 3, right? Or we could call that 3.0, we could call it 3 over 1, or we could call that 300% as a percentage. I'll just leave it as its decimal number, 3. Okay, let's go find our y-intercept. So where does this line hit our y-axis? So it's actually down here below the x-axis. And the coordinate of this point is at 0, walk 0, fall 3. Okay, so the y value of that coordinate, right? The y value is at negative 3. Okay, and that's also our b value, right? B is just a symbol for the point at which your line hits the y-axis. So if B occurs, our y-intercept occurs at y equals negative 3. Well, there we go, right? We've got our two significant values, right? We need B and we need our slope. As long as we have those two values, let's go plug it into our slope-intercept equation, right? I think I'll move it right here. Okay, so y equals slope times x plus or minus b. Like I told you, this could turn out to be a minus, right? And it is in this case. So here we go. Y always stays the same, equals slope. And that's a positive slope, by the way, right? This line is going up and to the right, so it's a positive 3 times your x value plus or minus b. In this case, it's going to be a minus, right? The line hits the y-axis at a negative y value below the x-axis, so it's going to be a minus 3. There is your slope-intercept equation for that line. Y equals 3x minus 3. Super simple, guys. All right. Well, hope this helps. I'll do a super new video later here on the special case scenarios, but hope this helps.